Okay, so 4.9, we are going to sketch these quadratics. So remember, a quadratic is anything that has an x squared in it. So we could say something like 0 equals x squared plus 3x plus 2. So this would be what's called a quadratic because of that x squared term. So now we're actually going to sketch these things. So the first thing we have to know when we're sketching them is what the graph is called. In terms that have the x squared, the quadratic equations, our graph is called a parabola. So the graph of a quadratic function is a parabola, and this is what it looks like. Now, a parabola is U-shaped, and this squared term tells us, remember, every time that we factored, so in this case, this one would factor to x plus 2 times x plus 1, and I use the diamond method on that, because 2 times 1 gives me 2, and 2 plus 1 gives me 3. When we solve these things like what we did on Friday, or Thursday, or Wednesday for this class, we had to set it equal to 0, and then we solved for x using the zero product property. Now, what that means is when we're setting the equation equal to 0, that's where the y usually is. So we're looking for the points where the parabola crosses the x-axis, and we call those x-intercepts. So when we're solving for x here, what we're actually finding is the x-intercepts. So to sketch a quadratic function, we have 4 steps. The first step is to factor that quadratic. The second step is to solve for x using the zero product property. So we're going to get 2 answers for x. Remember, whenever we use zero product property, we always got 2 answers. Step 3, we're going to plot those along the x-axis. And step 4, we can determine the direction of the parabola and sketch. So how do we determine the direction of the parabola? Well, we have parabolas that either go, we call them opening up, like the one in this example, or they could also open the other way, which we call opening down. So we look at that x squared term. Now, if the x squared term is positive, that means that the number in front of the x squared is a positive number, then the parabola opens upwards. If the x squared term is negative, then the parabola opens downwards. So let's try some examples. So example 1, y equals x plus 3 times x minus 5. Now this one is already factored for us, but it's not set equal to 0. It's set equal to y. This is what we call a function when it's set equal to y. Since we are looking for the x-intercepts, that means that we're crossing the x-axis, so anytime along the x-axis, y is going to be 0. So we want to set that equation equal to 0. So all I'm going to do is I'm going to plug in 0 for y, and then rewrite the whole thing. And now I can solve this using the zero product property, just like we did on Wednesday. So remember what I did here was that the first thing I did was draw a line down the middle, and I set this one equal to 0, so x3 equals 0, and I set this guy equal to 0, x minus 5 equals 0. So let's solve for the green one first. To solve for x, I subtract 3 from both sides, and I get x equals negative 3. And to solve the red one, I add 5 to both sides, so I get x equals positive 5. So the way I'm going to graph this is these are both x-intercepts. So they're going to come along the x-axis, and I need to put one of them at positive 5. So 1, 2, 3, 4, 5, and we need to make sure we label that. And 1, 2, 3, 4, 5, but those are negative. Okay, and I'm going to put the green one at negative 3. So I just put a dot on the x-axis at negative 3. And I'm going to put the red one at positive 5. So I'm going to put the dot right there. And now we need to determine whether or not the parabola is going up or down. So I need to look at the x squared term, or what's in front of the x squared. Now, since this one does not have a term in front of the x squared, but if we were to FOIL all of this out, we would get x squared is minus 5x, 3 times x is plus 3x, and 3 times negative 5 is minus 15. We combine those terms, so we get x squared minus 2x minus 15. The number in front of that x squared is a positive 1, so our parabola is going to open upwards. So I'm just going to draw a parabola opening upwards through those 2 points. And that's how we graph these things. So let's try another example. Same thing. Example 2, I have y equals x plus 4 times x minus 4. It's not equal to 0 yet, so the first thing I want to do is I want to set that y equal to 0. And then I'm going to use the zero product property here. So we're going to let x plus 4 equal 0. Subtract 4 from both sides, and I get x equals negative 4. And then we're going to let x minus 4 equal 0. So we add 4 to both sides, and we get x equals positive 4. Now these are my x-intercepts, so I'm going to plot those on my graph. 1, 2, 3, 4, 5. 2, 3, 4, 5. Negative. Okay. Now the green one is at negative 4, so I'm going to put a dot right at negative 4 along the x-axis. And the red one is at positive 4 along the x-axis. Now, I noticed in example 1 that the number in front of all of this was positive. Now this one is also going to come out positive. Since there's nothing there, there's an invisible 1. So it's a positive 1. So this one is also going to open upwards. So I'm just going to draw a parabola through those 2 points, opening upwards. And we need to make sure that we remember to put arrows at the end of those lines, because lines go on forever and ever. So we need to put arrows to show that they actually do go on forever. And then we're done with this one. So let's look at a negative one. Example 3, we have negative x minus 3 times x plus 1. And this one is also already factored for us, so the only thing we have to do is set it equal to 0. And this looks like distributive property, but since we want to factor all of this out, we're actually not going to distribute the negative into the parentheses, so do not distribute it. But it is going to tell us what our direction of the parabola is. So the first thing we have to do is just set each of those factors equal to 0. So I'm going to let x minus 3 equal 0. And I add 3 to both sides, and I get x equals positive 3. And then I'm also going to let x plus 1 equal 0. So I subtract 1, and I get x equals negative 1. So the first thing I want to do is I want to graph those. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'm going to put a point at positive 3, 1, 2, 3, and a point at negative 1, right here at negative 1. But this one has a negative in front of the factored parentheses. So that tells me that it's actually going to open downwards. So I'm going to draw an upside down parabola going downwards, and make sure that I draw my arrows. And then we're done with that one also. So as long as it is going in the correct direction and going through those 2 points, then we're good to go, because we're just sketching right now. So what about one where it is not already factored for us? So let's look at example 4 here. In example 4, I have y equals x squared minus 6x minus 7. So the first thing that I want to do is, this one is not factored, so I actually want to factor this. Now I'm going to go through all of my 4 factoring methods that we already have written up on the board, and the first thing I want to look for is a GCF. But there's not a GCF in here. This is also a trinomial because there's 3 terms, so it's not a difference of 2 squares. So what we have here, because there's no number in front of the x squared, is diamond method. So I'm going to draw my diamond, and I'm looking for two numbers that multiply to -7 and add up to -6. And as I'm going through the factors of -7, I know that 7 and 1, but one of them has to be negative, so that they multiply to a negative, and since they add up to -6, that 7 is the one that has to be negative. So this is going to factor to y equals x minus 7 times x plus 1. And now I can set the whole thing equal to 0. So we have 0 equals x minus 7 times x plus 1. And now I can set each of those factors equal to 0. So I have x minus 7 equals 0. X plus 1 equals 0. And to solve for this one, I add 7 to both sides. So I get x equals +7. And to this one, I subtract 1 from both sides. So x equals -1. So what I'm going to do now is I'm going to graph those. Remember, these are called x-intercepts. So they intercept the x-axis. And I didn't make enough. 1, 2, 3, 4, 5, 6, 7, 8. 2. Okay. So the first x-intercept is at +7. So 1, 2, 3, 4, 5, 6, 7. And the second one, the red one, is at -1. So right here. And then notice that my x squared, there's nothing in front of it, so there's an invisible 1, but that's positive. So my parabola is going to be opening upwards. So I'm just going to draw an upwards parabola going to infinity with the arrows at the end through those two x-intercepts. And then we're done. So let's try a -1. Example 5. We have y equals -x squared minus 1. So the first thing I want to do is this thing in parentheses, I want to factor it. So I'm going to go through our 4 factoring methods. We want to look for a GCF first, but I don't see one in here. So the next thing we want to ask ourselves is this a difference of 2 squares? Now x squared is a perfect square, and 1 is a perfect square, and they're being subtracted. So this is a difference of 2 squares. So what we can do here is just apply our rule. We have to bring that negative down, and then we make our parentheses. 1 is plus, 1 is minus, and then I plug everything in. The square root of x squared is x, and the square root of 1 is 1. So now I'm factored all the way. So I set the whole thing equal to 0. And then I set each of the factors equal to 0. So I have x plus 1 equals 0. And x minus 1 equals 0. And then we solve each of these. So for the green one, I subtract 1 from both sides. And the red one, I add 1 to both sides. And I get x equals -1 and x equals +1. So I just need to graph those. Remember, these are called x-intercepts. 1, 2, 3, 4. 1, 2, 3, 4. And I'm going to put the green one at -1 and the red one at +1. So this one's going to be kind of skinny. And look at our, in front of our x squared is negative. So this is actually going to be opening downwards, so I need to draw an upside down parabola and make sure it makes it through each of those x-intercepts. Okay, so example 6. This thing also is not factored all the way, so we want to look at each of these. So the first thing we always look for when we're factoring is a GCF.